The title of my talk will be Representing Land-Ocean Heterogeneity via Cape Relaxation Timescale in the Community Atmosphere Model. So as you can see, the title itself is very targeted. So I'm going to present very simple results of the work primarily done by Andrea Polacallo in the summer of 2023 when he was visiting Institute of Science and Technology, Austria, and I was working at that place. And also, of course, with Caroline. So, so to begin with, what is Cape Relaxation Timescale? I think I kind of explained a little bit during my earlier tutorial talk, but because I see few new faces, I'm just going to quickly quote Zhang McFarlane 1995 paper. So this is my like artist visualization of what Cape relaxation timescale means. So this is the triggering of convection, and this is how the convection would die out exponentially. And Zhang McFarlane said it's the adjustment timescale that determines how quickly or slowly convection will decay. And a shorter tau would mean it will decay quickly, but it will be an intense convection. And a longer tau would mean it's a long-lived but weaker intensity convection. So this is what we will play with. And people actually have played with tau for a long time because it's a very interesting and important and sensitive variable. See, even when Zhang McFarlane introduced their scheme in 1995 paper, they themselves tried with 3 values of tau, 2 hours, 4 hours, and 6 hours. And then Lee et al. In their single column experiments with CAM, they tried with maximum 8 hours. They actually had tried other values as well. Mishra et al. With Mishra in his 2011 and 12 paper, he tried 8 hours for CAM, and he looked at some monsoon features and equatorial wave features. And so this was the extreme of all. They tried from 1 to infinity in a CAM aquaplanet. And as you can see from these values, this is a very, from modeler's point of view, it's a very accommodating variable. You just give it any value and the model doesn't crash. It will run. So, but what is important to note is in all of these above studies, they used one single tau for like at least for the ones which used global model, they used 1 tau for both continents and oceans. So now I'll come to what's the problem if we use tau, one single value of tau for the whole globe, or just 1 hour, which is the out of the box tau value if you download CAM model. So observations suggest that tau is typically longer than 1 hour. So people like Bretherton or Angel Adames, I actually used to pronounce his name differently. I learned from Eric that it's Angel. So they looked at moisture adjustment, and they found it almost takes half a day for moisture to adjust. But then Fayaz Ahmad in 2020, they argued that it's for the moisture that the earlier studies didn't take into account the temperature contribution. So if you take temperature contribution into account, then they argue that 2 hours is a decent value. And the second problem is, and we have seen in different papers and different literatures that convection over land and ocean are different. They behave slightly differently. So it is not perhaps logical to use 1 tau value for the entire globe. So just for further motivation, I've already showed this picture earlier, that this is a deep, a fraction of deep convection plotted from Matsui et al. 2006 when they looked at TRIM data, and they found that there is deep convection typically occur more over land. And this is the tree of the explanation tree that they use, why the deep convection occurs typically more over continent. Essentially, it's deep planetary boundary layer and stronger updraft, and eventually they get more deep convection over continents. And it's the opposite for oceans. So, and yeah, this is also a repetition, so partly from my earlier talk, that with weaker updrafts over ocean, we see longer lifetime and more time to consume instability, more time to consume cape, and so we can use a longer tau. And over land, it's the other way around. So with that in mind, we designed a few experiments with different tau values. So we didn't have any specific observation to guide us what kind of value of tau we should take. So for us, we really didn't intend to find the exact tau value for which the model would perform the best. We just wanted to use these experiments as a proof of concept that if you use two different tau values, then the model might perform better, or at least we expected it to. So these are the tau values that we kept for land. So as you can see, we just didn't experiment much with the tau values over land. And over ocean, we just increased them by like 1 hour by 1 hour. And we just did both 4 hours, which we called experiment slow. And experiment fast is essentially control. We just named it experiment fast so that it makes the comparison more meaningful in terms of naming it. And all these simulations, we ran it for 1+5 means we just neglected first year and analyzed the last 5 years, and forced by climatological SST and people who are working with CAM or who have worked with, just for their reference, I have used the COMSET F2000 CLIMO. So with this, I'm going to present very quickly simple results, just 2 slides of results. One is to show that there was not a dramatic difference in terms of model mean. So people who have worked, how many minutes do I have? 4? Okay. So people who have worked with these tau experiments, they also had found like there is not a dramatic change in the mean. This is just the zonal mean profile of the different experiments, and observation is in gray from TRIM data. And yeah, as I said, there is not a big difference. But what we expected the model to do differently, or Mikhail is shaking his head, maybe he sees a difference that I didn't. Or I mean, yeah, there were differences, but yeah. So in the second plot, what I'm going to show is, like Eric showed, the MGO propagation. So on our left-hand top is observation, and these are the different experiments. And experiment fast, 2 hour, 3 hour, 4 hours, and slow. So in all experiments, except the 4 hour, every model shows a westward propagation of MJO. So this basically is the outlier in terms of simulating MJO propagation, or I should say it is closest to observation. And just to give you a reference, this is a result from Guo et al. 2015, who looked at sort of MJO MIP models, like 26 models that participated under MJO task force. And this is their definition of a model simulating bad MJO propagation. And this is good MJO propagation. So just by tweaking tau and making it longer over ocean, we somehow could magically turn a bad model into a good model. So one additional experiment we did, we just reversed it, just thinking that if we do the reverse, maybe it doesn't matter where we are doing the change. We just did longer over ocean, over land, and shorter over ocean. And this doesn't do the trick that this 4-hour experiment does. So with this, I would just summarize that our results serve as a proof of concept that we ideally should be using 2 different tau values, and preferably longer tau over ocean and shorter over land. And yeah, that already I said. And these results are, oh, sorry. Okay, this is fine. So another interesting point before I conclude, wanted to indicate that, as I said, people are still playing with tau because it's an interesting variable. So 2 papers, in addition to ours, came almost at the same time. This came in 22 August 25, and this is 10 August 25. And this paper said the larger value of tau generally improves MJO propagation. This one was more sophisticated in terms of designing tau, Pathak et al. And so how they designed tau was they had a cape calculation over whole globe, and they designed tau based on a cape. So the tau was a dynamic tau sort of, but they found MJO propagation was not good in their dynamic calculation of tau. So what it means is, yeah, this is just a screenshot of our paper. So what it means is we need to be, I mean, it's not just changing tau, but we need to be clever. How do we change tau? So, okay, thank you. I'm going to sacrifice a minute.
Sorry. Yes, we have good time for questions. 1, 2, then 3, and
4.
Hi. Yeah.
Short answers.
Yeah, sure. So my question is regarding the selection of tau over ocean and land. So in the context of MJO and MJO phases in the maritime continent where we have so much diurnal activity going on, the archipelago configuration. So how would that selection of tau be working in maritime continent? So where we have so much land and sea breezes going on, and that interacts with the background MJO.
Yeah, I don't know how that is. That would, like, I mean, as I said, these values are just like we checked the earlier papers and sort of decided, or like just pick. It was more of an ad hoc selection, so we didn't really put a lot of thought into what should be the value of tau. So yeah, I mean, and yeah, I think this Pathak et al. Is a proof that maybe too much detail is also might not be needed for this purpose. So, yep.
Your slide where you showed comparison of different experiments.
Yeah.
So we see previous slide. Always in observations, rainfall is less than the model output. Why is that?
Always
near equator.
So model is simulating wet bias, you mean?
Yeah. Okay. So you mentioned like there is no significant difference. So I'm just curious, what can be the significant difference? What value we can say it's a significant?
Yeah, I mean, it is. So when I plotted, I do not have this plot here. When I plotted global mean precipitation, then all the values were almost exactly same. So that thing was actually back of my mind when I said there is no dramatic difference. But when I go to more finer, like if I show you, this is what I plotted for total rain, but if I separate it into convective and large scale, so that's the reason why I'm using 3825, because that gives me convective and large scale rainfall. So because of that, we had to use this one instead of 3B42, more popular choice. So if I plot that, then you would see specifically this experiment 4R that does the shape well, the zonal shape of total to convective ratio. But then its value is much lower. So just because we didn't have much time, so I didn't show a controversial result. But yeah.
Yeah. So in your MGO that result, you showed that I think the EXP4 was showing you a good model, right? Apart from the all. So that means that does it mean that your ratio should be 1:4? Like if you change it, the land to 2 hours and then ocean to 8 hours, will it remain the same or it should always be 1 hour and then 4 hours? Like, have you tried that? I just wanted
No,
to know
no, we
that
didn't
variation.
try. We didn't try. And but yeah, that's something. I mean, we thought we will do this and at least motivate CAM developers to do 1 hour and 4 hour in their out of the box thing, or maybe if they do more sensitivity experiments.
Okay. Eric, if I'm wrong, let me know. But I thought that something similar happens with the entrainment parameter, right? That if you make the MJO better, you mess up the seasonal cycle or the climatology, right? So I think that that's probably why 1.1 is out of the box, because it gets less mean bias in the precipitation. Yeah. So I don't know. I don't know that there's been any an improvement in how to figure out how to optimize both at the same time, both the MJO and the annual mean. But it seemed to kind of want to go in different direction. I don't know. I don't understand why. So that was a comment/question. But the other one is about the diurnal cycle. If you looked at whether they gets you a better diurnal cycle.
Yeah, I mean, that's a very good point, actually. I think some people think alike. Simona also gave the same comment. Did you look at diurnal cycle? But unfortunately, we didn't output it that frequently. So, and yeah, I mean, because it was his summer project, we wanted to get things done quickly. We outputted, daily was the maximum we could output. So yeah, maybe if somebody wants, then we can do a branch and then do 1 year diurnal output and see how it happens. But yeah, regarding mean and the variability, that's again, that's a fair point. Like I have seen while working on SMCM, because SMCM had this many parameters, I could do, like, yeah, mean and variability goes in different ways. But this one, at least for this tau value, these tau values, the mean didn't change much. Like the map, the map, if we see it. So yeah, I mean, I can pull up the other maps and I can show you. So yeah. Thank you.
Thanks. Let's thank Bidyut once again.